Yes. Today we'll see an example where we'll discuss to trace a rose curve. So let us consider this example. Trace the curve r is equal to a sine of 3 theta. Now see the given equation is in the form r is a sine of n theta. So therefore it is a rose curve. We know that rose curve, equation of a rose curve is in the form r is a cos n theta, or it can be in the form r is a sine n theta. Here the given equation is in the form r is a sine n theta with n is equal to 3, which is an odd integer. We know when n is odd integer, we get the same number of loops. Here n is 3, so we'll get 3 loops in this curve. Now to check the symmetry, if we replace r by minus r and theta by minus theta in this given equation, the new equation we get becomes minus r is equal to sine of minus 3 theta. But we know that sine of minus x is same as minus sine x. So this minus sign comes outside. We get minus r is equal to minus a sine theta. Minus sign gets cancelled from both the sides. We get r is a sine 3 theta. So see, if we replace r by minus r and theta by minus theta in the given equation, the equation does not change. It remains the same. So the curve is symmetric about the line theta is pi by 2, or the line which is perpendicular to initial line and passing through the pole. So that is nothing but the y-axis. Curve is symmetric about y-axis, or you can say about the line theta is pi by 2. Now to check whether the curve passes through the pole and to find tangent at pole, we put r is 0 in the given equation. R is a sine 3 theta. We put r is 0, we get 0 is equal to a sine 3 theta. So we get sine 3 theta is 0. So see, sine 3 theta is 0. Therefore the curve must pass through the pole. See, always the rose curve will pass through the pole. We know sine of any angle can have values between -1 to +1. Here sine 3 theta we are getting 0, which is a value between -1 to +1. So therefore the curve is going to pass through the pole. So you can say that the curve passes through the pole. Curve passes through pole. Curve passes through the pole. And to find tangent at pole, see, if sine 3 theta is 0, we know that 3 theta can be 0, pi, 2 pi, 3 pi, 4 pi, etc. Because sine 0, sine pi, sine 2 pi, sine 3 pi, all of them are 0, we know. This is the value 3 theta can have. So if you multiply this whole equation by 1 upon 3, this 3 will get cancelled. We'll get theta is equal to 0 upon 3, that is 0, pi by 3, 2 pi by 3, 3 pi by 3, that is pi, 4 pi by 3, etc. So these lines, theta is 0, theta is pi by 3, they are nothing but they are the tangents at the pole. So these lines, theta is 0, theta is pi by 3, etc., they will be tangent to the curve at the pole. Now to find angle between the radius and tangent phi, so to find this angle phi, we know we have formula tan phi is r d theta by dr. Here in this example, r is given as a sine 3 theta. So therefore dr by d theta, the derivative of this term, will be 3a cos 3 theta. We know derivative of sine 3 theta will be 3 cos 3 theta. So the value of dr by d theta, if we take the reciprocal, we get d theta by dr is 1 upon 3a cos 3 theta. We substitute the respective values of r and dr by d theta by dr in this formula. R we know is a sine 3 theta, d theta by dr we have got as 1 upon 3a cos 3 theta. A gets cancelled. Sine 3 theta upon cos 3 theta will become tan of 3 theta. So we'll get tan phi is tan 3 theta divided by this 3. We have got the value of tan phi as tan 3 theta upon 3. We have to consider two cases. The first case we have to consider when phi is pi by 2. Phi is pi by 2 means radius is perpendicular to the tangent. We want to find the values of theta when radius becomes perpendicular to the tangent. Put phi is pi by 2 in this equation. We get tan pi by 2 is tan 3 theta upon 3. We know tan pi by 2 is infinity. If I substitute tan pi by 2 is infinity, we'll get tan 3 theta upon 3 is infinity. That is tan 3 theta is infinity. Tan 3 theta is infinity. 3 theta should have values like pi by 2, 3 pi by 2, 5 pi by 2, etc. Because we know tan pi by 2, tan 3 pi by 2, they are infinity. So 3 theta can have these values. Find the value of theta. If I multiply this whole equation by 1 upon 3, I'll get theta is pi by 6. 1 by 3 into pi by 2 becomes pi by 6. This 1 by 3 into 3 pi by 2 will become pi by 2. 1 by 3 into 5 pi by 2 will become 5 pi by 6, and so on. So these are the values of theta where phi is pi by 2. That means radius is perpendicular to the tangent. And When phi 0, phi 0 means radius is coincident with the tangent. Radius and tangent are the same line. We want to find the values of theta where radius becomes coincident with the tangent. So for that we put phi 0 in this equation. 1 will get tan of 0 is tan 3 theta upon 3. Tan 0 is 0. Tan 3 theta we get as 0. If tan 3 theta is 0, 3 theta can have values like 0, pi, 2 pi, 3 pi, 4 pi, etc. You multiply this whole equation by 1 upon 3. We will get theta is 0, pi by 3, 2 pi by 3, pi, 4 pi by 3, etc. These are the values of theta where phi becomes 0. That means radius is coincident with the tangent. Now, is the most important part of this. We prepare the table of values of theta and r. We know the given equation is r is a sine 3 theta. The first value of theta we take is 0. The last value of theta we take it as 2 pi in case of rose curve. So the second value of theta that we take is pi upon 2n. So this second value is most important value. Second value of theta we take pi upon 2 into n. Here n is 3 in this problem. So 2 into 3 becomes 6. So theta becomes pi by 6. See, the first value of theta we have taken 0. Second as pi by 6. Then we take the values of multiples of these values. Multiple of pi by 6, that is 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 6 pi by 6, 6 gets cancelled, becomes pi, 7 pi by 6, 8 pi by 6, 9 pi by 6, 10 pi by 6, 11 pi by 6 and 12 pi by 6. That is nothing but 2 pi. So we take the values of theta from 0 to 2 pi. The second value we have taken it as pi upon 2n, that is pi by 6 in this case because n is 3, and then we have taken multiples of pi by 6 till we get 2 pi. Now for the first 4 values of r, for the first 4 values of theta, we'll find r carefully. See, the first 4 values of theta are 0, pi by 6, 2 pi by 6 and 3 pi by 6. These first 4 values of theta we'll find r carefully. Now see, when theta is 0, first value of theta we are taking theta is 0. We substitute that value of theta here in this equation, that r is a sine of 3 theta. It becomes r is equal to a sine of 3 into 0. It will be sine 0 is 0, a into 0 will be 0. We get r is equal to 0. When theta is 0, r is 0. Similarly, when you substitute the second value of theta, that is pi by 6 in this equation, remember we are substituting theta as pi by 6. So r becomes a sine of 3 pi by 6. R is a sine of 3 pi by 6. That will become sine of pi by 2. And if you find the value of sine pi by 2, we know it is 1. R is a into 1. So r becomes a. When theta is pi by 6, r becomes a. The next value of theta we have taken is 2 pi by 6. Theta is 2 pi by 6. That is nothing but pi by 3. Put theta is pi by 3. That will become sine of 3 into pi by 3. That 3 gets cancelled. It becomes sine pi. We know sine pi is 0. A into 0 will be 0. If you have any doubt, you can find the value of sine pi, etc. on calculator. Bring your calculator in radian mode. And the third value of r we have got is 0. When theta is 2 pi by 6, r is 0. Next value of theta is 3 pi by 6. That is nothing but pi by 2. If you put theta is pi by 2 here, r will become a sine of 3 pi by 2. Sine 3 pi by 2 is minus 1. So minus 1 into a becomes minus a. So see, we found out the first 4 values of r carefully. For these values of theta, since we have got it as 0, a, 0, minus a. Remember, it's a periodic curve and these values will repeat in the same order again. So see, it was 0, a, 0, minus a. Again, it is going to be 0, a, 0, minus a. Again, the values of r will repeat in the same order, 0, a, 0, minus a. And again, when theta is 2 pi, r will be again 0. We will find the first and the last value of r will be always the same in case of rose curve. We have got these values of r and theta. So using this, we can draw the curve easily. Now see, when theta is 0, r is 0. Theta is 0, r is 0. When theta is pi by 6, r is a. Theta is pi by 6, r is a. So we have drawn a circle of radius a. We have drawn a circle of radius a, and we have divided each quadrant into 3 equal parts. Why 3 parts? Because n is 3. We have divided each quadrant into 3 equal parts of 90 divided by 3. That is 30 degrees each. See, this angle is 30, and from here it is 60, and this is 90. Or you can say the first quadrant, we have divided this 90 degree into 3 equal angles of 30 degrees each. So that lines we have drawn as theta is pi by 6, theta is 2 pi by 6. So that divides the first quadrant in 3 parts, also the third quadrant in 3 parts. Similarly, in the second quadrant, if we divide this 90 degree into 3 equal angles of 30 degrees each and draw these lines, we'll find the second and fourth quadrant also gets divided into 3 equal parts. And these lines we have labeled. See, the first is theta is 0, then theta is pi by 6, 2 pi by 6, 3 pi by 6, that is pi by 2, 4 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6, 8 pi by 6, 9 pi by 6, that is 3 pi by 2, 10 pi by 6, 11 pi by 6, and 12 pi by 6, that is 2 pi. So you will find these lines are nothing but the same values of theta that we have taken in the table. Now we can observe that when theta is 0, r is a. When theta is pi by 6, r is plus a. So here theta is 0, r was 0. When theta is pi by 6, r is a. First we are going to get here at theta is pi by 6. So as the value of theta increases from 0 to pi by 6, the value of r increases from 0 to a. And after again from pi by 6 to 2 pi by 6, as the value of theta increases from pi by 6 to 2 pi by 6, we can see that the value of r decreases from a to 0. Also we have seen that theta is 0, theta is 2 pi by 6. They are tangents at the pole. So see, we draw the first loop about this line theta is pi by 6 where r was plus a in such a way that the adjacent lines, that is theta is 0 and theta is 2 pi by 6, these two adjacent sides, they are tangent to the curve at the pole. And here at this point when theta is pi by 6, r is a, here we get a loop about that line theta is pi by 6. We get the first loop there. Then as the value of theta increases from 2 pi by 6 to 3 pi by 6, from 2 pi by 6 to 3 pi by 6, there we can see that r becomes negative. So we are not going to get that portion in this portion of the curve, but in the opposite quadrant in fact we'll find. Okay, so again from 4 pi by 6 to 5 pi by 6, r increases from 0 to a. We can see that r is plus a for the next time. For theta is 5 pi by 6. See, theta is 5 pi by 6 is this line. There r is plus a. From theta is 4 pi by 6 to 5 pi by 6, r is increasing from 0 to a. And again from 5 pi by 6 to pi, r is decreasing from a to 0. So see here at theta is 5 pi by 6, r is plus a. And at 4 pi by 6 and 7 pi by 6, r is 0. So these lines are tangent to the curve at the pole. Theta is pi and theta is 4 pi by 6. Theta is pi, 4 pi by 6. There r is 0. They are tangent to the curve at the pole. So we draw the next loop about the line theta is 5 pi by 6 where r is plus a. We draw the loop in such a way that theta is pi and theta is 4 pi by 6 are the tangents at the pole. Already we had seen that at theta is 5 pi by 6, the tangent and the radius are perpendicular to each other. Pi by 2 there we have seen. Also at theta is 5 pi by 6, the radius and the tangent, they are perpendicular to each other. And yes, then again r becomes plus a when theta is 9 pi by 6. We can see that when theta is 9 pi by 6, r is plus a. And 8 pi by 6 and 10 pi by 6, there r is 0. That means radius is perpendicular to the tangent at that point. So when theta is 9 pi by 6, r is a, the next loop will get about the line theta is 9 pi by 6 and the adjacent lines 8 pi by 6 and 9 pi by 6, they are tangent to the curve at the pole. So we'll get these three loops. What happens with minus a? See, when theta is 3 pi by 6, theta is 3 pi by 6, r is minus a. If r was plus a there, we could have drawn the loop here itself. It is negative. So on the same line in the opposite quadrant, we get that loop of 3 pi by 6. Similarly, when theta is 7 pi by 6, r is minus a. So see, 7 pi by 6 is this line, there r is minus a. So on the same line in the opposite quadrant, we have got the loop. So when you will find n is odd, we get the same number of loops. Like in this case, we get n is 3 and the loops are also 3. See, to draw that curve, we divided each quadrant into 3 equal parts of 30 degrees each. First loop, in case of sine curve, when r is a sine n theta form, first loop is drawn about the line theta is pi upon 2n, which in this case was pi by 6. So first loop we draw about theta is pi by 6. And since there are 3 loops, it is called as 3-leaf rose curve. And you can see that maximum value r can have is plus a. The entire curve lies within a circle of radius a. The entire curve is going to lie within the circle of radius a. So we have seen that as theta changes from 0 to pi by 6, r increases from 0 to a, and from theta is pi by 6 to 2 pi by 6, r decreases from say a to 0. Same thing happens here. From theta is 4 pi by 6 to 5 pi by 6, r increases from 0 to a, and 5 pi by 6 to pi, r decreases from a to 0. Right? So we get these three loops in case of this rose curve. Right? I hope you have followed this, how to trace this rose curve.